Hi, I'm going to talk about Gaussian elimination, which is in section 8.1. So Gauss elimination, we're going to be talking about with 3 variables and 3 unknowns. So the first thing we do is we want to put our system of equations as an augmented matrix. And then our goal is to make our matrix look like this over here so that we have 1s on the diagonals and 0s everywhere else. Okay, so how we do that is we try to get 1 right here, and then we try to get 0s below it by multiplying this row times the opposite, whatever coefficients we have. And then we try to get a 1 right here, and that's usually by dividing this row by something or switching rows. And then we try to get a 0 here by multiplying this row by the opposite of whatever is right here. And then finally we want to get a 1 right here. Once we have that, we can go ahead and put this back into a system of linear equations and solve it. And then just as a couple reminders here, this is from the earlier slide, for row operations, you could switch around 2 rows at any time, and that's fine. You can multiply any row by a non-zero number. And the last one is you could take any number, any row, multiply by a non-zero number, and add it to another row. Okay, so those are the things we want to keep in mind. Those are all row equivalent. Okay, so I was going to go ahead and look at this particular example. This is from the homework example. There's also one in the PowerPoint. I'll just kind of go through these steps here. Okay, so the first thing I would do is I'm going to write this as an augmented matrix. So these are my x's, my y's, my z's, and then we have the equal sign as this vertical line, and then we have these constants. Okay, so the first thing I want to do is I want to have a 1 right here. So what I do is I just switched row 1 and row 3, and that's what this represents. So I just switch those 2 rows. Okay. The next thing I want to do is I want to get a 0 right here. So I do that by multiplying my row that has a 1 in it by the opposite. So I multiply this row times -4 and add it to this row. And I did the work over here. So this is -4 times row 1, so -4 times all of these. And then I rewrote row 2, and I add them together. And this is my new row 2. So my row 1 and row 3 are the same. This is my new row 2. Okay, the next step I want to do is get a 0 right here. So I multiply this row times -5 and add to this row. Again, I did the work right here. I took a -5 times row 1, add to row 3, and then this is my result. So this is my new row 3. Next step I want to do is get a 1 right here. So I take this whole row and divide by 21. So 1 over 21 times row 2, and I get this. Now I want to get a 0 right here. So I take this row times -24 and add to this row. That's what I did right here. Again, the work is over here. It's kind of messy with some fractions, but you can look over this. A copy of this is on Canvas. This is my result. Now my last step I want to do is I want to get a 1 right here. So I take this whole row and I multiply by the reciprocal. The negative reciprocal, I guess. No, it's a reciprocal, 7/10. -7/10. So I get a 1 right there. Okay, so now I'm at the last step. Now I already have the 1s on the diagonal and the 0s down here. So I'm actually right here. So now what I'm going to do is go ahead and write this as the linear system. So I have x minus 4y plus 0z is equal to 15. Y plus 17z is equal to 34 over 7. And z is equal to 6. Okay, so now I'm going to go ahead and solve for both of these. All of these, I have z. So now what I do is I plug z into this equation. And I get y to be 4. Okay, there's y. And then I plug 4 for y into the first equation, and I get 1. So my answer is 1, 4, and 6. Okay, so that is this example. I'm going to make an example just like this, but I'm going to show you how to do this in the calculator in the next video.